For 34 years, astronomers have been playing the largest game of hide and seek in human history, and until very recently, they were losing. Since the first planet orbiting a star other than our own was confirmed in 1992, scientists have found more than 6,200 worlds scattered across the galaxy. Gas giants bigger than Jupiter, scorched rocks orbiting so close to their stars that their surfaces are literally melting. Frozen wastelands drifting alone through the dark with no star at all, 6,200 worlds, and not one of them checked every single box on the list that actually matters. Not one of them was small enough, rocky enough, warm enough, and wrapped in an atmosphere thick enough to seriously ask the question, could something be alive down there? Until now. In July 2026, a team of scientists confirmed something that has been theorized, chased, and quietly hoped for since the very beginning of exoplanet science. A planet sitting just 48 light years from Earth that appears to have everything. The right size, the right temperature, and for the first time in the history of this search, direct evidence of a real atmosphere wrapped around it. Its name is LHS 1140b, and by the end of this video, you're going to understand exactly why scientists are calling it the most Earth-like planet ever found. How they managed to detect an atmosphere on a world 280 trillion miles away, and why this single discovery might just have changed the odds on one of the biggest questions humanity has ever asked. Let's get into it. To understand why this discovery matters, you first have to understand just how absurd the entire hunt for Earth-like planets has always been. Stars are blindingly bright. Planets are not. When you're trying to find a small, rocky world orbiting a star that outshines it by a factor of billions, you're essentially trying to spot a firefly hovering directly next to a lighthouse from the other side of an ocean. For most of human history, this was simply impossible. We had no tools capable of it. That changed in 1992, when astronomers detected the first confirmed exoplanet, a strange, unexpected discovery of a world orbiting not a normal star, but the collapsed corpse of one, a pulsar sitting 2,300 light years from Earth. It proved planets existed beyond our solar system. It also proved almost nothing about whether any of them could support life, since a planet orbiting a pulsar sits bathed in lethal radiation. The real search began in earnest with NASA's Kepler Space Telescope, launched in 2009 with one explicit mission: figure out how common Earth-like planets actually are in our galaxy. Kepler worked using something called the transit method. As a planet crosses in front of its star from our point of view, it blocks a tiny, precise fraction of that star's light, dimming it just slightly on a regular, repeating schedule. Astronomers describe the effect as being roughly like removing a single light bulb from a wall of 10,000 of them and watching for the barely perceptible dip. It sounds impossible. It isn't. Kepler pulled it off more than 2,600 times before retiring in 2018, and along with ground-based and other space-based telescopes, it helped push the total confirmed exoplanet count past 6,000. But sheer numbers were never the goal. The real goal, the one astronomers have been chasing this entire time, is what scientists call the habitable zone jackpot, a planet small and rocky like Earth, orbiting its star at exactly the right distance for liquid water to exist on its surface, wrapped in an atmosphere thick enough to hold that water in place and shield the surface from radiation. For 34 years, across more than 6,000 confirmed worlds, nothing had ever checked every one of those boxes at once. Here's the twist in the story that makes it even more interesting. LHS 1140b isn't a brand new discovery. Astronomers have actually known about this planet since 2017, when it was first identified using that same transit method, spotted as a small repeating dip in the light coming from its host star. What changed in 2026 wasn't the discovery of the planet itself. It was astronomers finally getting close enough, with instruments good enough, to answer the one question that had been left hanging for nearly a decade. Does this planet actually have an atmosphere? The star LHS 1140b orbits is what's known as a red dwarf, a small, relatively cool type of star with surface temperatures somewhere between roughly 3,100 and 5,800 degrees Fahrenheit, compared to our own sun's blistering surface temperature of around 10,000 degrees. Red dwarfs are, by a wide margin, the most common type of star in the entire galaxy, making up roughly 3 out of every 4 stars out there. That matters enormously for this search, because it means if planets like LHS 1140b turn out to be common around red dwarfs, the number of potentially habitable worlds across the Milky Way could be staggering. Because red dwarfs run cooler than our sun, a planet needs to orbit much closer to stay warm enough for liquid water to exist. LHS 1140b does exactly that, sitting roughly 9 million miles from its star, about a tenth of the distance between Earth and our own sun. It completes a full orbit, its entire year, in just 24.7 days. Using both the transit method and a second technique called the radial velocity method, which measures the tiny gravitational wobble a planet induces in its host star as it orbits, scientists calculated The planet's basic vital statistics. LHS 1140b is roughly 1.7 times the diameter of Earth and about 5.6 times Earth's mass, placing it in a category astronomers call a super-Earth. Bigger than our planet, but still fundamentally rocky rather than gaseous, still built more like a boulder than like a balloon of hydrogen and helium. Size and orbital distance told scientists this planet was, on paper, sitting in the right neighborhood. But being in the right neighborhood isn't proof of anything by itself. The next step was the hard part. Here's where astronomer Colin Cherubim, a researcher at the University of Chicago and the lead author of the new study published in the journal Science, enters the story. Years earlier, while completing his PhDs in Earth and planetary sciences at Harvard, Cherubim built a computer model designed to predict which distant planets were most likely to actually have detectable atmospheres. Feed the model everything. Known about a planet, its diameter, its density, its age, how long it takes to complete an orbit, and how strongly its gravity should be able to hold onto gas. And it generates a prediction about what that planet's atmosphere, if it has one, should look like, and what it should be doing. When Cherubim ran LHS 1140b through his model, it produced a very specific prediction. The model suggested the planet should have a real atmosphere, and that atmosphere should be actively leaking helium into space. Helium is an extremely light gas, one of the easiest elements in the universe to lose to space entirely, which paradoxically makes it a useful signpost. If a planet is bleeding detectable helium, it's strong evidence that planet has a genuine, complex atmosphere underneath, one substantial enough to be losing gas at a measurable ongoing rate. That was still just a prediction, a number generated by a model sitting on a computer on Earth. To test it, Cherubim's team went back to the transit method, but pushed it further than a simple light dip measurement. As LHS 1140b passes directly in front of its star, some of that star's light doesn't just get blocked, it passes straight through the thin edges of the planet's atmosphere on its way to our telescopes. Any molecules or atoms present in that atmosphere, like helium, absorb very specific, precise wavelengths of that starlight as it filters through. Astronomers can then examine the light that reaches us and look for those exact missing wavelengths, essentially reading a chemical signature written directly into the starlight itself. The absorption signature was there, precisely where the model predicted it would be. LHS 1140b was confirmed to have a genuine helium bleed, hard evidence of a real atmosphere wrapped around a real rocky planet, sitting squarely inside its star's habitable zone. For the first time in over 3 decades of searching, a planet had checked every box simultaneously. The right size, the right temperature, and now, finally, direct proof of an atmosphere. A pure helium atmosphere. On its own wouldn't be much to get excited about. Helium is chemically inert. It doesn't react, doesn't combine into anything more interesting, doesn't do the kind of complex chemistry that makes an atmosphere like Earth's genuinely dynamic. Our own air is a constantly shifting mixture dominated by nitrogen and oxygen, laced with methane, carbon dioxide, water vapor, and dozens of trace gases, all interacting with the surface, the oceans, and on Earth specifically, the living things that helped shape it over billions of years. But Cherubim's model suggests the helium detected around LHS 1140b might just be sitting on top of something considerably more interesting. Running the same modeling that predicted the helium bleed in the first place, Cherubim's team found strong indications that carbon dioxide should be the second most abundant gas in the planet's atmosphere, with carbon monoxide also present in meaningful amounts, along with small quantities of molecular oxygen. And based on the same climate modeling used to make those predictions, the team calculated that LHS 1140b likely holds a substantial quantity of water. Read that list back: carbon dioxide, carbon monoxide, molecular oxygen, water. That is, essentially, the basic ingredient list you would write down if you were sitting down to sketch out the recipe for a planet capable of hosting biology. None of it is proof. None of it confirms anything is alive, or ever has been, on LHS 1140b. But it is, by a wide margin, the most complete and promising combination of ingredients astronomers have ever detected together on a single confirmed rocky world sitting in its star's habitable zone. Here's the piece of this story that made LHS 1140b's habitability genuinely plausible, rather than just theoretically possible on paper, and it has everything to do with the star itself. Red dwarf stars have a well-earned reputation among astronomers for being dangerous neighbors, even when their planets sit in the technically correct habitable zone. These stars tend to be volatile, prone to violent flares that blast out enormous amounts of X-ray and ultraviolet radiation, more than enough to strip away a planet's atmosphere entirely, or sterilize its surface outright. The nearest known example sits uncomfortably close to home. Proxima Centauri b, part of a 3-planet system orbiting the closest star to our own sun, just 425 light-years away, technically sits inside its star's habitable zone too. But its star, Proxima Centauri, is a notoriously hostile red dwarf, bombarding that planet with up to 400 times the X-ray radiation Earth receives from the Sun. Most astronomers now consider Proxima Centauri b almost certainly sterilized, its surface scoured clean by decades of relentless stellar radiation, a habitable zone planet in name only. LHS 1140b caught a very different kind of break. Its host star, while still a red dwarf, turns out to be unusually calm and quiet by red dwarf standards. The planet receives roughly 10 times the X-ray flux that Earth gets from our own Sun, a meaningfully elevated amount, but nowhere close to the sterilizing intensity hammering a world like Proxima Centauri b. According to Cherubim, the level of radiation reaching LHS 1140b right now would not pose a serious threat to life as we understand it. It's elevated. It isn't lethal. That distinction matters enormously because it means LHS 1140b isn't just theoretically warm enough and rocky enough, it's also plausibly safe enough. All three of the major roadblocks that have sunk previous Earth-like candidates, wrong size, wrong temperature, and a hostile radiation environment, appear to be absent here at the same time. That combination has simply never been confirmed together before. It's worth being precise here, because it's easy for a story like this to drift into overstatement, and the actual scientists involved are careful not to let it. None of this proves life exists on LHS 1140b. Nobody involved in the study is claiming that. Life requires an enormous, complicated cascade of chemical and thermal conditions to actually get started, and confirming even a genuinely favorable environment is a very long way from confirming biology. LHS 1140b could have every single ingredient on that list: water, carbon dioxide, a shielding atmosphere, a calm star, and still be as dead and empty as the moon. What this discovery actually proves is narrower, but still enormously significant. It proves that a planet meeting every major criterion scientists have used to define genuine habitability, correct size, correct temperature, and a confirmed atmosphere actually exists, and is sitting close enough, in cosmic terms, for us to study it in detail. And for 34 years, Earth-like was a description built out of theory, statistics, and hopeful extrapolation. As of July 2026, it's a description that fits a specific, confirmed, atmosphere-bearing world 48 light years from where you're sitting right now. And the scale of the universe suggests this almost certainly isn't a one-off. There are, by conservative estimates, hundreds of billions of stars in our galaxy alone, the overwhelming majority of them red dwarfs, just like the one LHS 1140b orbits. If a planet with this exact combination of traits, the right size, the right temperature, a real atmosphere, and a survivable radiation environment, exists just 48 light years away, well within our own tiny local corner of the Milky Way, the statistical implication is difficult to ignore. If one world like this is close enough for us to already be studying it, there's very likely no shortage of others scattered throughout the rest of the galaxy, simply waiting for the next generation of telescopes powerful enough to find them. LHS 1140b isn't going anywhere, and neither is the scientific interest in it. Now that its atmosphere has been confirmed, the planet becomes one of the highest priority targets for follow-up observation, using the most powerful instruments currently available, including deeper, more detailed spectroscopic studies aimed at directly confirming whether the predicted carbon dioxide, carbon monoxide, and oxygen are really there, and in what quantities. Every additional measurement narrows the uncertainty a little further. If future observations confirm substantial water and a genuinely complex layered atmosphere, LHS 1140b will move from being simply the most Earth-like planet ever, found to being one of the single most important targets in the entire search for life beyond our solar system. A real place, with a real address in the sky, worth pointing every future telescope humanity builds directly at it. We spent 34 years combing through more than 6,000 worlds, hoping to eventually find one that checked every box at once. In July 2026, we finally did. It's sitting 48 light years away, orbiting a calm, quiet red dwarf star, wrapped in an atmosphere that might just be hiding water, carbon dioxide, and the basic chemistry of a living world. Nobody knows yet whether anything is actually down there. But for the first time in more than 3 decades of searching, we finally have a planet worth truly wondering about. If this story gave you chills the way it gave the researchers behind it, let me know in the comments what you think we'll find when we finally get a clearer look at LHS 1140b's atmosphere. And if you want to keep following the search for another Earth as it unfolds in real time, subscribe, because after 34 years of near misses, this might only be the beginning.